you're already going through the
Yeah,
whole.
that's the only. FDR.
He did it, I'm sure. That one, that's because that was in the video yesterday.
And then I didn't know what.
Do you remember what Route 66 was?
No. I have no idea.
I was gonna put golden something now. Because there was definitely different. But I didn't think that was right.
Alright, ready to start?
Yes, sir.
Okay, so what have we been doing for like the past week now?
Limits.
Limits. Okay, we're gonna, we're still gonna talk about limits, just keep that in the back of your head, because for a little bit, it's gonna seem kind of unrelated to what we're doing, okay? Alright, so the last 30 seconds of the last class, we kind of started, we looked at a graph like this, alright? Y, X. Alright, and we took some function. It can start anywhere, but we'll just start at the origin, doesn't matter. Something like that. Alright, and what were we trying to look at? Yeah, y. Alright, so we were looking at the slope of, I don't know, any point, right? So if we have just a line, we can easily find the slope, right? How do you find the slope of a regular line? Yeah, you think of that formula? That m equals... No, the answer. Alright, well, even super simple, remember, back in the day, rise over run. Alright, so you can find the slope of the line, and that slope stays the same for the whole thing, right? Alright, so how is this different? Yeah, that slope is changing. So what's the slope like here? Positive, negative, or zero? Alright, what about here? Alright, what about here? Alright, so it changes. So it's not just, we can't just look at it and we can't just do a rise over run and say, okay, the slope of this function f of x is 3 or something like that, right? So we can get rid of this. But what we can do is we can look at a single point, say right there. We can look at a single point, draw a tangent. Actually, I can do the, let's see. That looks better. Alright, so I can draw the tangent line like that, and we can find the slope of that, right? If we knew a couple things, right? That's just a line. We know how to find the slope of a line. But what do you need to be able to find the slope? Right, you're going to need more than just 1 point. 1 point doesn't tell you anything. You're going to need 2 points. Once you have 2 points, then you can use the slope formula, which we're going to review in a little bit. So how can we get 2 different points? Sure, so we can keep this one the same, and we can just pick another point. Let's say this point. Alright? And let's see. We can make a line. Make a line through that point. What's that line called? A secant line. Okay, we can make a secant, and we can find the slope of that because it goes through 2 points, right? And we can use that to estimate the slope of the tangent line. But is that close to the tangent line at all? No, the slope of this is not even close. Right, so we can move this a little closer. You guys just said it. Draw this. We can move this point right here. Alright, and then draw another line. So now, is that closer? Is the slope of that secant line closer to the slope of the regular line? I mean, it's a little closer, right? It's more similar. Alright, how can we make it even closer? Alright, so let's add something to this before we move even more. Let's say that this point here, let's give them quantities. Let's call this one x, because we're on the x-axis, right? So this is any quantity x. This is x anywhere on this, all right? And then we're going to say that this distance between them, so we're moving over a distance, right? We're for finding this change in distance, we're going to say that this distance is h. Okay? That change in x is h. So what does that make this point, or this value, this x value? X plus h. Okay. So what did we do when we moved that point over a little bit? What did we do to h? Yeah, we made it smaller. Alright, so then we can do it again. Alright, so now we'll move it here. Alright, and we can make another secant line. Alright, so alright, that one, the slope of that secant line is even closer to the slope of the tangent line, right? Everyone agree? Alright, and once again, we can keep moving it closer and closer and closer. Alright, so now we're like this, that's pretty close. You wouldn't need the line. But that's pretty close, right? So as we get closer, as we make h smaller, the slope of that secant line is coming closer to the slope of the tangent line, right? Everyone agree? Alright, so we're making that x really, really, really small, really, really close to 0. What's that sound like? A limit. So we're making a limit. A limit of what?
X.
As not x. Right, we're keeping x the same, but we're making h. So as h approaches,
Is this the
That's
the song? The song. Yeah.
there's a song.
There's
I'm sure there's a song actually. Yeah, this is as h approaches 0. We want that h. Yeah, okay.
Yep.
You guys have seen this. That's good. Okay. So as h approaches 0, we're making that distance between x and x plus h really, really, really small. And we said that as we make h really small, as those 2 points get closer and closer together, then the slope of that secant line is getting closer and closer to the slope of the tangent. Alright? Now just like when we're doing limits, why can't we just say, oh well, we'll just look at it when h is equal to 0. What happens when h is equal to 0? You're just left with this. You're just back to having just one point, right? You can't put a slope to a point. That doesn't make sense. So we're just getting h as close to 0 as possible. Really super, super, super close to 0. That way that distance is really small. That way the slope of the secant line that connects those 2 points is really close to the slope of the tangent line. Does that make sense?
Yes.
Okay. So, alright, I'm gonna shrink this so we can keep it. That's not what I want. Do you know the song?
But I'm not singing it right now. Can ask TK to find the video.
Oh, I believe it. There's a song.
Can we
Alright.
watch the video tomorrow?
Sure. Tomorrow we'll watch the video of the song, apparently. Okay, can you guys still kind of sort of see what's going on?
No, the video's not good.
Okay, so let's write the slope of the secant line, okay? So you guys started to say it before, little rusty, this is back, this is going back a ways for you guys. Alright, so what is the equation for slope?
The change over
We change over y, we change over x. Okay, so we can write, there we go, that's what I'm looking for. y2 minus y1 over x2 minus x1. Alright, so that's to find the slope. We can apply that to any line. Okay, so we're going to apply it to our secant line because we want that secant line to estimate the slope of the tangent line. Alright, so we have m, we're finding the slope of that secant line. What is our y2 value? What's our y2 and our y1? Now, how did we define this? Did we say this is y equals something? No, yeah, so we said f of x2, right? Because we're talking about y2, we're talking about that second point. F of x2 minus f of x1 over x2 minus x1. Okay. But, tell me what x2 is. X plus h is x2 is x plus h. And then what's x1? X1 is x. Okay? So now we can just put that in. So we have our m equals f of x plus h minus f of x over x plus h minus x. Good so far? Alright, so we can see those go away. X minus x is 0. So m is is just f of x plus h minus f of x over h. Alright, and what are we going to do to h? Back here, or right here, what are we doing to h? Right, we're making it really small. We're seeing what happens as h approaches 0. So we're taking the limit. Yeah. Okay, so we're taking the limit as h gets really close to 0. Okay, so is the limit as h approaches 0 of f of x plus h minus f of x over h. Yeah, sure. Why not?
What's it called though? I don't know. It's like.
I know probably exactly what you're talking about. Alright. So that's something you guys are gonna need to know. Apparently there's a song, so obviously just look it up. Okay. Derivative song. It's gotta be there.
I think he probably has a
He probably does. Alright, we'll look it up tomorrow, okay? We'll find it. Alright, so if there's a song, where did I put that pen? Alright, so this is important, and this is the formula. Alright, so does everyone have this written down? Can I go to a new page?
No.
Okay. I'll write it over here then. What we call this is just f prime of x. Alright, so f prime of x is that limit as h goes to 0 of f of x plus h minus f of x over h. So if you guys ever forget that formula or something, it comes right from the slope formula. So if you know the slope formula,
What's that thing?
this thing, that's a little prime. So remember when you were doing translations and stuff, you had like your point A and then your point A prime, and that was after the translation. This is pretty much, this is your new function. So this comes from f of x, so we call it f prime of x. Alright? Now based on what I just said, what is this? What does this represent? What does that function represent? What did we go through and find?
The slope of
The slope of the tangent line, right? So the slope of the tangent line, what's the slope of the tangent line represent for this function? Yeah, this is tricky stuff.
Restate the question.
Sure. Okay, so we have our function, and we look, I'll draw another one. We can zoom in to right there, okay? We'll zoom in right there, and we have this curve here. Alright, so we draw a tangent line to it right there at that point. Then what does the slope of that tangent line mean? What does that tell us? The slope, yeah, the slope of the function at that point. Right, so we talked about before, the slope of this function is changing constantly, right? It's changing, I guess you shouldn't say constantly, because it's not a constant, but it's changing at every instant. So at that single point, we can find the slope right there by getting the slope of the tangent line. Does that make sense? Alright, so then when we move over a little bit, if we move over to this point, then we have a new tangent line. And now the slope at that point, it's called the instantaneous rate of change, the rate of change being the slope. So the instantaneous rate of change for that point, we can find the slope of the tangent line at that point. Alright? So when we do this and we estimate it by making this h goes to 0, so that distance really small, it's almost like we're zooming in. So now we zoom into a curve, and eventually if we get close enough, it's just going to look like a line, right? Because we're going to keep zooming in really close to this one point. When you get really close, your window is getting smaller, your h is getting to 0, and eventually it looks like a straight line. And so when we find the slope of that line, we know the slope of the function at that point. Alright? So let's write this again over here. This f prime of x is what? Oh, yep, you're right. The limit as h goes to 0 of, okay, minus f of x over h. Okay, so f prime of x is that. Alright, so what's your answer going to be? With all our other limits, we plug in, or we look at these x values and we get y values as answers, right? We get these numbers as values. Alright, what's this going to give you? Yeah, this is going to give you a new function. This is a function of x. So you're going to take this limit as h goes to 0, and you're going to get a new function. And that function is going to show you the slope at any given point. Okay? So it's pretty much like, it's pretty much like you're combining all of these tangent lines, finding the slope of all of that, and you're turning into one function, so that one function represents the slope at all the points. Okay, so I know that sounds kind of weird, but when we do an example, it's going to make sense. Alright? Kind of like a lot of things in this class, I feel like. Alright? So all that means is that when you get your new function, let's say you're looking for the slope of this function at this point. Let's say this x is 2. Alright? Just to throw a number in there. X is 2, and we want to find the slope at x equals 2. Alright? Then we find f prime of x by taking the limit as h goes to 0. That represents the slope at any given point. So if we plug in x equals 2, your output will be the value of your slope at that point. Alright, so again, when we do an example, we're going to do one right now. I'm going to show you. That's going to make sense, okay? So let's look at the function f of x equals, pick any number.
8.
8. Okay. There's your function. What's that look like? Or what's the slope of this line? 0. And so what's it look like? It's just a horizontal line, right? Of 1, 2, 3, 4, 5, 6, 7, 8. Alright, so the slope of that line, you guys just said, this has a slope of 0. Alright, so according to what I just said, that function is going to be a function representing the slope of this at any given time, okay? So if you plug in any number to this function, you're going to get the slope at whatever that value is, okay? Slope equals 0, sorry. Right, does that make sense? Horizontal line, the slope 0. Alright, so let's just use this. Let's just plug this in, okay? So let's find f prime of x. By the way, I don't know if I said this, the actual formal name for this is called the derivative. Alright, so f prime of x is called the derivative, or this function of the slope is called the derivative. Okay? Alright, so let's plug it in. F of x is the limit as h goes to 0. Alright, so f of x plus h just means wherever you see an x, you're going to plug in x plus h instead. Alright, so wherever you see an x, put in x plus h. Okay, so what's f of x plus h? Is there any x's? No, so it's just that 8. Okay, minus f of x, found it. It's 8, right? Minus 8 over, really? Stupid board. Over h. 8 minus 8 is 0. 0 over anything is 0. So, this proves it right there. The slope of that line at any point, let's say you want the slope at x equals 3, plug in 3 to your new equation, and what do you get? 0. Okay, so that says the slope at x equals 3 is 0. We knew that, right? Alright, plug in 5. Okay, plug in 5, what do you get? 0. So the slope at that point is 0. We knew that, it's 0 everywhere, right? Alright, so that's the little baby example, alright? That's like the tutorial on the game, just not difficult. Alright, so now we're going to go to level 2, okay? Level 2, f of x is x. Alright? F of x is x. X, that function has a slope, right? So let's draw this graph quick. Alright, so what's the graph look like? It's a line through the origin, okay? And what's the slope? 1. The slope of just x is just 1. Okay, so the slope is 1 when? Everywhere, the whole time. So if we apply that f prime of x is the limit as h goes to 0 of f of x plus h minus f of x over h, we should get the slope at any given point, which should be 1. Okay, so let's do it. Alright, so f prime of x, the derivative of f of x, is the limit as h goes to 0. Okay. Now what's f of x plus h this time? So anywhere we see f of x plus h, or anywhere we see x, we're going to plug in x plus h. Okay, so what's f of x plus h? X plus h. See an x, plug in x plus h. Okay, so x plus h minus f of x. What's f of x? X. Right? F of x is just x. Divided by h. Okay, so this is the limit as h goes to 0. X minus x is 0, so you just end up with h over h. What's anything divided by itself? 1. What's the slope? 1. Okay, is there a little confusion on where the whole, when you put in x plus h?
Yeah.
Alright, if I told you what is f of 3, what would you say? How would you find that out, given this function? Plug in 3. So what's your answer? 3. Alright, if I tell you plug in negative 2, then what do? Plug in negative 2. Alright, if I tell you to plug in smiley face, then what's your answer? Smiley face, okay. Then if I tell you to plug in x plus h, then what do you get? X plus h. Does that make sense? Yes. Does that make more sense? Okay. If I tell you to get any function, any value of a function.
But you get x,
Right. So look at this one. So we're looking for f of 3. Then you plug in 3 wherever you see an x, right? So I see an x. So really, I'm plugging 3 in for x. This one, now I'm plugging in negative 2 for x. There's your x. You just plug in negative 2, then you just end up with negative 2. Alright, so then you plug in some random symbol. All this means f of anything. Then you just plug in that whole thing for x. Alright, we see an x, then you just get whatever's inside the parentheses. Alright, so now f of x plus h, you're plugging x plus h in anywhere you see an x. Alright, so I see an x right here, I see one x, so I just plug that in wherever I see an x, and you just get x plus h. Okay, we're going to do another example, and then we'll see if that makes sense after, okay? So now let's do, alright, so everyone understands the slope is 1, right? Okay, now let's do another example similar to this one. Alright, f of x is x plus, pick any number. 4. Okay, x plus 4. Alright, let's graph it. What's this graph look like? Okay, and a slope of 1. Alright, and you guys said that the slope of that line is 1, right? So what should I get when I find that limit as h goes to 0, that whole thing? 1, because the slope is 1 the whole time. Alright, so f prime of x is that f of x plus h minus f of x over h. Oops, limit, sorry, forgot that. That's important. The limit as h goes to 0. Wow, this pen. From another ink. It's a 0. See, 0. Perfect 0. Alright, so there's the formula. Okay. So f prime of x is the limit as h goes to 0. Alright, f of x plus h. So what am I plugging in wherever I see an x? X plus h, okay, so I'm going to put that in the parentheses. I can do it in normal parentheses. Alright, so we have x. I see an x, so I'm going to plug in x plus h, okay? X plus h. okay, plus 4, can't forget that. Alright, minus f of x. Okay, what's f of x? X plus 4, okay, so minus x plus 4. Divided by h. Okay, now it's algebra. The limit as h goes to 0 of x plus h plus 4 minus x minus 4 all over h. All over h. Alright, what cancels out?
4.
Alright, the 4's, the x's, and what are we left with?
H over H.
Which is limit as h goes to 0 of h of h. Anything divided by itself is 1. Alright, so technically it's the limit as h goes to 0 of 1, which is just 1. Okay, so what's that say?
The slope is 1.
The slope is 1. We knew that, right? So notice you get the same answer for that one and this one. The y-intercept didn't matter because you're finding a function for the slope, right? Not the y-intercept, just the slope. Okay, now these are easy. You could have told me, you did tell me what the slope was before we even did that, right? So that's an easy one. So we're going to amp it up a little bit, all right? So now, let's look at, all right, x squared, oh, I'm going to put f of x, sorry. F of x squared, all right, now name the rest of it.
3x.
Plus 3x
Plus 1.
plus 1, okay. All right, so what's that look like? It's a parabola, okay. So what's the slope of a parabola? Slope of a parabola, it's changing, right? Here it's negative, here it's 0, here it's positive, so we don't know, all right? So we're going to try to use that formula to find a function that represents the slope of that line, okay? So f prime of x is the limit as h goes to 0 of f of x plus h minus f of x over h. Sing the little song in your head if you have to, you know it. Okay, so what do I do? Yes, this one's going to be a little bit more difficult, right? Not more difficult, it's just going to be more algebra. Okay, I'm going to start over here. F prime of x is the limit as h goes to 0 of, what's f of x plus h? All of what plus h? Now what's f of x plus h mean? What do? You plug this value in for x, right? So wherever you see an x and an x, you're going to plug in x plus h. All right, so what do I get?
X plus H squared.
X plus h squared
Plus 3x plus H.
plus 1.
Plus 1.
Okay, now what?
Minus
Minus
X squared.
f of x. We know f of x, it's right there. X squared plus 3x plus 1. All over h. Now, again, it's all algebra from here. Alright, so I'll start over here. F prime of x. Alright, so this x plus h squared is really x plus h times x plus h, right? That's what x plus h squared is. Okay, so we distribute everything. What do we get?
X squared plus 2x plus h squared.
Plus h squared. Okay, plus 3x plus 3h plus 1.
Shouldn't be 2 again.
Yep, you're right. Good catch. Thank you. So x squared plus 2xh. Is that where it is? Did I miss anything? Alright, plus 2xh. Okay. Right, we get it from this term and from that term. Okay, plus 2xh plus h squared plus 3x plus 3h plus 1. Alright, so that's a whole bunch of stuff. Alright, minus what? X squared. Minus 3x. Minus 1. All over h. And tell me what I forgot. I messed up again. Tell me what I forgot.